In this lesson, we look at what we call simple equations, and simple equations are like 1 or 2 step equations, the equations that you learned about in 6th grade and 7th grade. We're going to get more complex this year, way more complex than you've seen before. So it might sound a little tedious. It might feel like I'm making you do things that you can do in your head or type in your calculator, but it's really important that you write all your steps down, because we want to build the foundation of what's to come in those more complex equations. If you don't have a good foundation, then when you get to the really hard equations that you can't simply do in your calculator or in your head, you're not going to have the format down. So if I write it down, you write it down. The first thing that we're going to define is what an equation is, and an equation is a statement that says two expressions are equal. And when we solve an equation, we call it the solution. So that's the value that makes the equation true. Now we're going to use these things that we call inverse operations. And those are the things that we use to remove numbers to make the variable be alone. So in this first example, example 1, we're going to look at basic level equations, which is when we only have one operation. We call them one step, and we're going to do inverses. So the first question you say to yourself is, what operation do I have? And the operation that you have in example 1a is subtraction. So I'm going to remove that by using addition. Now, some teachers like to put a line down the equal sign to separate the two parts. It doesn't really matter to me, but I'm going to add 3 because that's what's going to get the variable alone. So I get x equals -2. Now, you want to make sure that you check your answer to make sure that it is correct. Also, the directions tell me that I have to check, so I have to do it. And what you do is you go back into the original equation and you just plug in -2 where the x is. So this means -2 minus 3. And then you check, is -2 minus 3 -5? And it is. So I got it right. You can put a check. You can put a smiley face, whatever you want to put. Why don't you try letter B on your own? Make sure that you show your steps. Alright, so that's what I got. If you didn't write something down that I wrote down, make sure you add it. Remember, we're building the foundation, so even if you can do it in your head or type it in your calculator, you have to write it down. Alright, now in example 2, we're going to look at multiplication and division, and then also some two-step equations. So the process is still the same. I'm going to multiply in letter A because I have division, and the inverse of division is multiplication. Now I'm actually going to multiply by -5 since I have this negative sign out here. So you don't just want to multiply by 5 because that won't cancel the negative sign. So I have to multiply both sides by -5. And I'm going to use parentheses instead of the x because the x just looks like another variable. So then I have n equals 15, and I'm going to plug it in to make sure that it's right. -15 over 5 equals -3, and that's true because I know that 15 divided by 5 is 3, and a negative divided by a positive is a negative. Alright, in letter B I'm going to divide because I have a number next to a variable, and anytime you really have anything next to a variable, it represents multiplication. Oh, I didn't put the line down the equal sign, but like I said, it doesn't matter. So now I'm going to get my calculator out, and I'm going to divide, because I don't know what that is off the top of my head. 5.2 divided by 1.3 is 4. So let me check. 1.3 times 4. Again, I'm not using the x because the x looks like a variable. So in 8th grade, we're going to use either the parentheses or the dot, preferably the parentheses. Remember, we're not even really in 8th grade. Our brains are in 9th grade, and this is 9th grade math. And when I multiply, I get 5.2 on the right, and it was 5.2 on the, or I get 5.2 on the left, and it was 5.2 on the right. Okay, now in letters C and D, we want to think about what operations we have. So if you look at letter C, you have multiplication, and you have addition. So then the question is, well, how do I know which operation I'm supposed to get rid of first? Does it matter? And the answer is yes, it does. Now we want to use GEMDAS or PEMDAS. I like to use the G stands for grouping symbols because there's more grouping symbols than just parentheses. But you can call it whatever you want as long as you do it correctly. So we know the order of operations is GEMDAS, but when you're solving equations, you want to go backwards in GEMDAS. You want to do back in the backwards order of GEMDAS. So if I have multiplication and addition, when I go backwards, the first thing I'm going to get rid of is the addition, and then I will get rid of the multiplication. So we're going backwards to solve the equation. So first thing I'm going to do is I'm going to subtract 2. So we'll get 3x equals 12. And now I have multiplication, so I'll get rid of it with division. X equals 4. Let me check. So I'm going to plug in 4 for x. And I'll get 12 plus 2 equals 14. And 12 plus 2 is 14, so that checks. Okay, if you want to try letter D on your own, you can pause the video and do it now. If not, follow along with me. So I'm going to draw my line down the equal sign, and I'm going to look and see I have division and I have subtraction. So if you go backwards in GEMDAS order, you're going to get rid of the subtraction first. So I'm going to add 6, and I get a over 3 equals 14. And now I have division, so I have to get rid of it by multiplication. Remember, I'm not using the x, and that tells me that a equals 42. So now I go in, and I'm going to plug it in where the a is. 42 over 3 minus 6 equals 8. Let me get my calculator out. 42 divided by 3 is 14. And that does give me 8. So I got 8 on the left and 8 on the right. Alright, in example 3, we're going to look at a word problem, and when you solve any word problem, you want to kind of look through these steps. First thing is you want to obviously understand the problem, so you have to read the story, find out what they want to know. Then you're going to come up with some sort of plan to solve it. You will then solve whatever plan you came up with, and then the last step is you want to look back and make sure that your answer makes sense for the story. So let's read example 3. In the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. So this one's the first example. They kind of gave us the answers to those questions above. The first thing is we have to know what the question wants. So we know the winning time, we know the distance based on what they gave us in the story, right? 200 meters and 19.32 seconds. And we're asked to find the average speed. So what was his average speed when he was running? So they give us the plan also, and they tell us this formula. You might have seen it in science. D equals RT. D stands for distance, R stands for the rate or the speed, and T is time. So let's solve this problem. They kind of gave it all to us. So the distance was 200 meters. The rate is what we don't know. And the time was 19.32 seconds. So that's the equation that we would set up. And now let's solve. So I'm going to divide by 19.32. And I really have no idea what that is, so that I have to rely on my calculator. 200 divided by 19.32 is, I don't know, it says to estimate, it says round to the nearest hundredth. So that's 2 decimal places. So that would be 10.35, and his speed would be in meters per second. Or if you wanted to abbreviate, it would be m/s. That is the label for meters per second. So now you go back and you say, does that make sense? In the story, he's running about 10 meters per second. And if he's running 19.32 seconds, 19 times 10 is 190. So that definitely makes sense because the race is 200 meters. All right, we got one more example. Now, before we look at this example, there are a bunch of different ways that you can solve a word problem. So you can solve it by coming up with an equation like we saw in the last one. Or you can draw a diagram, you can look for a pattern, you can work backwards, right? I'm not going to read this list, but these are all the things that you can do to solve a problem. It doesn't have to always be an equation like we did in the last example. So let's try a different method in this example. Example 4. On January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to negative 4 degrees Fahrenheit at 9:27 a.m. How many degrees did the temperature fall? So that's very specific in terms of the time. It doesn't say anything about the rate. It actually just wants to know how many degrees the temperature went down. So the time is really irrelevant to the story, how long it took. They just want to know how many degrees it went down. So I'm going to use the example up here, which is sketch a graph or a number line. So at 9 o'clock, it was 54 degrees Fahrenheit. And then at 9:27, it was negative 4 degrees Fahrenheit. So what I want to know is how far apart are 54 and negative 4. So if I think of the number line, these are 58 degrees apart because it would take me 54 degrees just to get to 0, right? If there was a 0 marker here, it would be 54 degrees to get to 0, and then it would be another 4 degrees to get to negative 4. So I know that it's 58. So now that's my answer. Let me do step 4, which is look back just to make sure that I did it correctly. So if it went from a positive to a negative, it went more than 54 degrees, right? Because 54 would be what I need to make 0. So it does make sense. It's a little more than 54. And I feel like I got it right. My number line makes sense. And if you have any questions, write them down and ask me when you come to class.